Hello, algebra students. Mr. Lawrence here, and we are with our third part of our review video. That's why I'm posting them nice and early for you. Test is Friday, and posting is early Tuesday. If you hear a loud pitch scream in the background, it's not a person. It is noon on the first Saturday of the month in Medina, which means the tornado siren is going off. Not because there's a tornado, but just because they do a test. Anyway, here we go. So we've got this situation here. Now, some of you are going to want to distribute. I'm going to recommend that you don't distribute. But I'll tell you what, I'll do it by distribution first. And then I'm going to show you a way that Natalie Zapka knows how to do. Okay, so we're going to get a y. And I'm going to get 2/3 x. And then minus, if I want to put that over 1, I'm going to have 4/3. Okay. And now I don't like those fractions in there. So here's where I'm going to multiply through to get rid of my fraction. Okay. You only do this if you distribute it first. Okay. So I'm going to multiply by 3 on that side. And I'm going to multiply by 3 over 1 on that side. Now the left-hand side is simple enough. It's just 3y, right? The right-hand side, 2/3 x and times a 3 over 1. And then we have a minus 4/3 times a 3 over 1. Okay, so now the left-hand side again is only 3y. The right-hand side, the 3's cancel. I have a 2x and a minus the 3's cancel, 4. So now it becomes a relatively simple problem. I'll add 4 to both sides. And I will get 3y plus 4. And that will equal 2x. X is almost alone. There's a 2 attached to it. I'll have to divide by 2. And then I have to remember to distribute. And I will get 3 over 2y plus 2, and that'll be equal to x, and that's it. Now, that's a perfectly viable way to do that. Nothing wrong with that method. I would do it one of two other ways because it would be quicker. Okay, now one thing would be to multiply. I'm not going to erase that answer because that's a good answer, and I'm going to just put it over here for now. Okay, one way would be to multiply right now on this step. So I'm going to multiply to get rid of my fraction, and that means that I'm going to multiply by 3 over 1 and then by 3. And I'm going to get 3y, and over here on the right hand side the 3's will cancel, and so I'll have 2 times the quantity of x minus 2. I'm not going to go 3, I should get rid of those guide arrows, those from the last problem. I'm not going to distribute the 3 and to the 2 to the x and to the 2 again, because it's only going to get distributed once, not twice. If I put it here, multiply this by 3, then distribute, I'm really distributing the 3 too many times. I'm over distributing. The simplest way to think about it is, oh, I multiply this part first, because in the commutative property, I don't have to multiply any one number before the other. Like if I had, 3 times 4 times 5, I could get the right answer by doing 3 times 5 times 4, right? I don't have to do 3 times 4. So I don't have to do the distribution first. I can do this multiplication first, and then I'm ready to do the distribution here. Okay, so I'm going to get a 3y, and that's going to equal 2x minus 4. This should look familiar to the last solution, and I'm going to divide by 3, divide by 3, divide by 3. Uh-oh. Oh, do I have a small mistake? I think I do. Hold on one second. Okay, I realized my mistake. I was starting to solve for y, and I'm asked to solve for x. It's more common in algebra to solve for y in a problem like this. You'll know that later on down the road, but that's my mistake. I didn't make a mistake early. I was making a mistake right there. So I'm going to add 4 to both sides, and then I'm going to get 3y plus 4, and that's going to equal 2x. And then I'm going to divide by 2, divide by 2, and divide by 2. And so I'm going to get 3 over 2y plus 2, and that's going to equal x again. And notice I get the same exact answer. Okay, so right there. Now, the other way that you might want to do it, and this is the way Natalie Zabka knows how to do it, is when you have a fraction like that that you want to get rid of, you can actually get rid of the whole fraction in one step. Okay, there's an old saying in math that dividing by a fraction, so in other words, 5 divided by 1/2 is the same as multiplying it by the reciprocal. Okay, so 5 divided by half is the same as 5 times a half, and I think most of you know that because, 5 and half the group, that's what this first problem means. And we've got 1, 2, 3, 4, 5. Well, then there's 10 in the whole group, right? And 5 times 2, of course, is 10. So why am I telling you that? Well, look right here. Oops, I lost my problem. All right. I could undo this multiplication here by dividing by 2/3. But that would be the same as multiplying by 3/2, the reciprocal. So I'm going to multiply by 3/2, put the y over 1, and here's what happens. I get 3y over 2. Okay, that looks an awful lot like 3/2 y, right? And here, 3's cancel, 2's cancel. I get x minus 2. I add 2 to each side. I get 3 over 2y plus 2. That's equal to x. And notice it's the same exact answer. Okay, so you're free to do whatever method you like. I recommend either this method or the previous one, but those aren't the only good ways to do it. These seem to be quicker. All right, last two problems. We're going to translate and solve, and we have 6 less. That means minus 6. 3 times what? 3 times a number. We don't know the number. Is 12. I got my equation. I start with the variable. I need 3 times that number. I need 6 less than it equals 12. I'm ready to go. So I'm going to add 6. And I'm going to get 3x equals 18. Divide by 3. Divide by 3. X is going to equal 6. I can test it. If I do 3 times 6, I get 18. If I take 6 away, I do indeed get 12. I'm good. It checks out. All right, one last problem, and then that's the end of the review video. The difference, I'm going to be subtracting 10, that's the first number, 10 minus the quotient, there's division going on, of a number, and 2 is 7. There's my equation right there. So I've got 10 minus x over 2 equals 7. Now you could either subtract 10 from both sides first, or you could multiply through by 2. I think I'm going to subtract the 10 off. I'll get negative x over 2 equals negative 3. Then I'm going to multiply both sides by negative 2. The negatives will cancel, the 2's will cancel. I'll be left with x. Negative 3 times negative 2, positive 6. Oh, wow, this is kind of a coincidence that they both ended up to be the same number. Uh-oh, but I have a problem. Oh, no, I don't. I wanted to do an inequality, but the typo says is. How about let's change this to is at least 7. Okay, that means it could be 7 or more. So let me back up here because it's going to change a little bit of my procedure. And this side here can be 7 or more. So that would be greater than or equal to 7. So when I go to solve, 10 minus x over 2 is greater than or equal to 7. Same first step, subtracting 10. I have a negative x over 2 greater than or equal to negative 3. And now I'm going to multiply by negative 2 on both sides. And whoop, 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 you should have some warnings going off here. When I multiply or divide by a negative, the inequality changes direction. Negative 3 times negative 2, positive 6. This negative 2 will cancel with that negative 2. I'll be left with x. And there we go. Now, on a number line, how does that look? I locate the number 6. It's equal to, so I have a filled in circle, a closed point, and I need numbers less than 6. Find me a number that makes this true. Well, 4 is less than 6, right? And 4 would be here. So I am going to shade toward the number 4, not stopping at the number 4, going on forever. Because as you move to the left on the number line, the numbers get smaller and smaller. Anyway, that's it. Mr. Lawrence signing off. Good luck on your test. Good night, everybody.